Hello, and thanks for stopping by. This is just a quick video to show you a problem that I took and ran into, and kind of a word of warning when buying components online. Um, I've been working on the BDST, as you all know, and the board itself, I think, is going to be fine right now. I've been working on the probe and was getting inconsistent results. And this is what I found that the problem was. Um, when I first started working on this, uh, these are the diodes that I originally bought. They were listed as 1N34As, and they seemed to work fine. I was getting consistent results out of them and stuff like that. But they're not the cheapest. They were just a hair pricier for all the experimenting I was doing. So I went looking for others, and there was two others listed. There were some listed that looked like this, with the DO35s. They have like a blue end on them and brown on the other end. They're listed as 1N34As. And then there were also some that look like this that were listed as 1N34As. So I took and got those, checked the voltage drop across them, and they were almost identical to those originals I was using, right around 2.8, 2.9 volts for a voltage drop. So I figured it's just like an updated version, and I started using those, and that's when I started running into trouble. And the other strange thing is when I took and bought those blue-ended ones, this second one here, this style, just the plain brown ones, those are what I got. So I took and got out the oscilloscope and started doing some testing with it. And this is what I found. This picture here, this is like a Heathkit T4 probe, just a single diode and a 1 nanofarad capacitor in series. This is using the original style diode that I had. And then this is using the newer diodes. And you can see it's a lot flatter waveform, a lot smaller waveform, as far as amplitude's concerned. So then I took and made up boards. I took and found two of my originals, and I took and made up uh, identical boards with the original style diode that I was using and the supposed 1N34As that were looking like those little brown ones. With the original, this is the output of the probe. And this is feeding it in with a 455 kilohertz modulated tone, and just getting out the audio portion of it, which is what I was using for testing on all these pictures. And you can see that's nice. That's almost 800 millivolt peak to peak. Nice clean signal. And on the same range, this is what it is with the newer diodes. You can see again, it's a lot flatter. This is only like 70 millivolts peak to peak, so nowhere near the voltage output, and looks nowhere near like a sine wave. And if you take and change the volts per division to take and blow it up a little bit, you can see that it's not a clean wave even. there's, a lot of distortion on the wave. So what I think is happening is I think they are selling, this is the same exact waveform you get if you use a Schottky diode. So I think what they're doing is just selling Schottky diodes as 1N34As since they both have the lower voltage drop. How can you tell the difference between them? Well, all the ones, definitely if they look like the original, if they look like this, with the clear tube, double black ends, these all appear legit. If you take and you do a measure the current, if you reverse bias them, take and try to put them in the current circuit backwards, you'll find that these do have a leakage. They'll leak up to 500 microamps with like 40 to 50 volts on them, type thing. The Schottkys won't. And from what I've read, germaniums are supposed to have a slight reverse leakage. So there's that. So just, buyer beware. The others are loads cheaper, but you're not going to get anywhere near the performance out of them in a circuit that actually calls for a 1N34A. So I have a bunch of good ones on order now. I hope to get this all bundled up, get it to Doug so he can get it to the beta testers or whatever, and we'll go on for there. So thanks for stopping by. Everybody have a good day.